Okay, in our next chapter, we're going to do a very, very brief overview of statistics and probability. And so before we dive into this section, we need to have just a general, and I mean general understanding of what statistics is. So in this case, statistics is the process of collecting, organizing, and then analyzing data. So you go out there, you find some topic you want to research, you go and you collect a bunch of information, you get a lot of data. You then need to find some way to organize that data. And one way that we can organize that data is with visual representations. So we have four of them we're going to look at in this section. We're going to look at pictographs, bar graphs, histograms, and line graphs. And they all can be used in different ways. So there's going to be certain situations where one of these might be useful and another one may not. Okay, so we're going to look at when you would use them, advantages and disadvantages as well. Okay, so in our first video or our first topic, we're going to look at the pictograph, which is probably it's almost juvenile in nature. They're kind of silly on some level because you quite literally use little pictures. They almost look like little emojis to represent your data, okay? So they have that very juvenile nature to them. They're not super precise at all, but it's a really quick way to get some information about your data set. So for our definition, a pictograph, is it going to let me? There we go. So a pictograph is a visual or graphical representation of data using images or symbols, okay? And then you do need a key, okay? In just a bit, we're going to look at an example of wheat production in certain states in the US, okay? And we have these little tiny pieces of wheat that represent our data. Well, we have to know like how much each little piece of wheat really represents. So you have to have a key that tells you how much each image is going to represent. So what do the images represent and how much of that thing do they represent, okay? Now, you can use fractional images to represent fractional bits of data, but this is where the pictograph becomes not the most precise method for visually representing our data, because if you're dealing with little, almost, again, like imagine little emojis, you can only cut those emojis into like really simple fractions, like maybe thirds, maybe fourths, generally just half, okay? So because of that, all of our initial data has probably been rounded when we made our pictograph because we want it to get as close to a whole picture or maybe half a picture as possible. Okay, so the data is not going to be super, super precise, but you do get a really quick understanding of what's going on. Okay, so advantages and disadvantages, easy, 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 easy to use. Okay, quick, easy comparisons can be made. Disadvantages, it can be difficult to tell what fractional part of a symbol is used. And so because of that, we kind of are limited to very basic fractions. So generally halves, maybe fourths, maybe thirds. Okay, so you have to be really careful about that. So tread lightly, use caution, and know that these values are not going to be overly precise. Okay, let's go ahead and look at our example here. So you have a pictograph and you're going to have generally two pieces of information that you're looking at. In this case, we have a little sentence at the top that tells us kind of what's going on. So I've typed out the following pictograph shows the number of acres of land devoted to wheat production in selected states in very specifically 2017. And then you can see the actual pictograph. Okay, so at the top it says that we're looking at annual wheat acreage in selected top states. And that's going to be kind of this horizontal, let me use a different one. It's going to kind of be this horizontal bit right here. Okay, and then we have the states, that's sort of this vertical bit right here. So the states are along what we would call the vertical axis, and the actual annual wheat acreage is along what we would call the horizontal axis. And if you get into an algebra class where you talk more about graphing, you're going to talk like X and Y axis. Here, we'll just say vertical and horizontal, okay? And then we have our key. Our key is over here, and it tells us each piece of wheat represents 1 million acres. Okay, so we can see pretty quickly at a glance, we're talking about North Dakota, Kansas, Montana, South Dakota, Texas, Oklahoma, Colorado, and Washington. Okay. And then we know each little piece of wheat is 1 million acres. Okay. So you kind of have to familiarize yourself with your pictograph and then you can go and answer your questions. Okay. Now, how many more acres of wheat are grown in Texas than in South Dakota? So let's look at Texas and South Dakota. So South Dakota, we have two pieces of wheat. So we know that when we were collecting this data, the amount of wheat grown in South Dakota is not necessarily exactly 2 million acres. It's going to be really close to 2 million acres. Okay. So we're going to say approximately 2 million acres in South Dakota. And then Texas, we have 4.5. So we have 4.5 sprigs of wheat. So we're going to say this is 4.5 million acres, okay? So again, it doesn't mean that Texas has exactly on the nose 4.5 acres of land devoted to wheat production, but whatever value of acreage that was devoted to wheat production in 2017 was real close to 4.5. It would have rounded to 4.5. It was closer to 4.5 than 4, okay? So, how many more acres did Texas grow than South Dakota? Well, we would take 4.5, subtract 2, and we would say 2.5 million, I don't know why, I cannot spell today, million acres more devoted to wheat in Texas. So always write your answer, at the very least put a unit. So 2.5 doesn't mean a lick of anything to us. It's 2.5 million acres. And then it's really nice if you can just give a quick description. So 2.5 million acres more devoted to wheat in Texas. Okay. Next up, we have that there are 34 million acres of wheat grown in these 8 states. Okay, so we're told that the total wheat production, or the total acres, was 34 million. Okay. So in these 8 states, we've got 34 million acres of wheat grown. What percentage of the wheat is grown in Kansas? So let's look at Kansas. Kansas is really killing it on wheat production in 2017. They've got 1, 2, 3, 4, 5, 6. They've got 7.5 pieces of wheat. So we're going to say approximately 7.5 million acres of wheat. Okay. So Kansas is 7.5 million acres. Total, we were given, remember, I don't know why I put an exclamation point there. Total was 34 million. Okay. And we want to know what percentage of the total wheat grown happens to be in Kansas. So let's figure out our amount and our base. Now, the base is the entire quantity being considered. So in this case, the entire amount of wheat grown throughout these 8 states, that's going to be the base. So that's the 34 million. Okay. And then Kansas is some portion of that. Okay. So that tells me that Kansas is the amount. Now, you can use the percent equation or the percent proportion. Literally does not matter which. I'm going to use the proportion here just because that's the first one that came to mind. So remember, the percent proportion is the amount over the base equals the percent over 100. And because we're putting that percent over 100 and we're converting it to a fraction, you do not have to mess with your percentage here. You don't have to move it into decimal form or anything like that. Okay, so let's fill in our numbers. We get 7.5 over 34 equals P over 100. So we cross multiply. And remember, I always cross multiply the diagonal that contains the variable. That's just what I do first. It doesn't matter though. So let's see, I'm going to get 34 times P equals 7.5 times 100. So let's see, we get 34P equals, well, when I take 7.5 and I multiply it by 100, I get 750. Okay, so in order to get the P alone, we would divide both sides by 34. So we're going to get that P is, I'm assuming it's going to be approximate. I don't think we're going to get an exact percentage here. So let's round to the nearest 1/10 of a percent, so 1 decimal place. Okay, so we need to take 750 and divide it by 34. Oh dear, do I have my calculator up? I think it's here. Yeah. So we're going to take 750. We want to divide it by 34. And we get 22.05. So if we were going to round 1 decimal place, that the 0 is where we're rounding. The 5 tells me to round up, so I make the 0 a 1. So we get 22.1%. Okay? So we get 22.1%. It barely fits on my screen. I can actually rewrite that and scoot it a little bit. So 22.1%. There we go. So that it tells us that 22.1% of all of the wheat that we're looking at is grown in Kansas. All right, last up, we have what is the ratio of wheat grown in North Dakota to wheat grown in Montana? So let's look at North Dakota and Montana. So North Dakota, we have 1, 2, 3, 4, 5, 6.5 pieces of wheat. Montana, we have 1, 2, 3, 4.5 pieces of wheat. And so we're interested in North Dakota to Montana. So North Dakota to Montana, well, we have 6.5 to 4.5. And in order to simplify this, to write this as a ratio, we do want to simplify it. We're told very clearly here in the directions to simplify it. So this kind of depends on each of you. You can go to your calculator and let your calculator do this, or you can rewrite this by eliminating the decimals from your numerator and your denominator. To do that, we just multiply by 10. So if I multiply the top or the bottom by 10, I have to multiply the other one. So I have to multiply both the top and the bottom by 10 because what I'm really secretly doing is rewriting the top and bottom into equivalent values. This right here, this 10 over 10 is just a weird form of 1. So it's not changing the value of our ratio. It's just changing our numerator and denominator, making them more useful, but it's an equivalent ratio. So we get 65 to 45. Both of these numbers end in 5, so that tells me they're both divisible by 5. Now, 45 is easy. That's 9. 65 divided by 5, you may need a calculator to help you, but 65 divided by 5 is 13. So the ratio of wheat grown in North Dakota compared to Montana is 13 to 9. Okay, so that's a pictograph. Again, it's super easy to use. All right, not the most precise, so you're not going to get super exact values here. Okay, like in your actual pictograph, we're dealing with probably rounded values, but that's okay because once we have our pictograph, pulling information is quite simple.